bars going
the
down?
integers.
Yeah, the integers, I agree. You guys okay with this?
What's that?
What's that? Yeah.
It's a Z. Hi, yeah.
I think you need the ruler.
Wait, what's that Z supposed to mean?
Well, the Z is what you always use Z for. Back in algebra, it's just a set of integers, isn't it? You use n for natural numbers, 1, 2, 3, 4, 5. The integers are all the naturals and they're negatives and 0. Q stands for the rationals, which are just fractions or numbers that can be expressed in ratio of integers. Then you build a bigger set called the reals. And by the way, we lied to you. We never really gave you a rigorous definition. We just hand-waved and said, oh, think of the reals as a collection of rationals and irrationals. We will not prove to you or derive the real numbers or carefully describe them until you finish a full year course called Real Analysis. Then we'll get a better idea what the real numbers are. But you can build above that and get the set of complex numbers. Oh, I didn't finish, sorry. I forgot the second equation. This implies the first factor is equal to 0. Well, not really. Or the second one is equal to 0, namely the cosine of y is equal to 0, but that implies that y is, you math 8 experts, is
Pi over k plus k pi?
pi over 2 plus k pi. Okay, all right, slow. For all k element of the set of integers.
Is that a smiley face or something?
Cheapers. Oh, did I mess up?
So you don't treat sine of y as a constant or dx as a constant?
Well, I did do the differentiation process. So everybody, I am going to check my function d at these critical points. So by computing d, I get, gosh, it's getting late. I get, don't want it.
Where are we computing it at?
Well, don't we have this, the second partial of f respect to x?
Oh, yeah. Okay, dx cosine y.
Say it again.
But we don't have anything that works for both of them.
Do you see my point?
We don't have. So then
I've got to find solutions to this equation. Both these conditions have to be true simultaneously. And y cannot be equal to this set of numbers and this set of numbers simultaneously. Did you guys see it? So I think when it comes to my d function, it doesn't even really matter here because I end up yielding no critical numbers. Or excuse me, I meant to say critical points, not numbers. And since I have no critical points, what can you say about local extrema?
no local extrema.
No local extrema. Or am I wrong? Did I make a mistake? Because maybe you and I should have thought of this as a sinusoidal wave being enveloped in some exponential curve. Maybe I made a mistake because doesn't something like this look like this, graphically speaking?
It doesn't just undulate?
Yeah, that's what I'm saying. Do you think I made a mistake? Because it looks like that. I should have a lot of local extrema. But what?
Cosine function are never 0 at the same time in this situation.
But Alex, I just want you to look at this function though. I mean, isn't it behaving like that?
Well, wouldn't you set bounds, and then that's where you find the local
There
extrema?
aren't any. I'm allowing x and y to range over all of this.
So the problem is that you separated out, you set each term to 0 without taking into account how they affect each other.
That's better, but I think we shouldn't even look below the line. I think you should just go to the original function. I think since these variables are different, the surface is not behaving in that fashion. I think it's behaving sinusoidally in the y direction, but exponentially in the x direction. And that's why the image doesn't look like this.
Is it
And that's
stretching out kind of then?
in a sense it is. It's the surface going up like this, but there's going to be no local extrema on the surface. Ooh, you don't like that.
Yeah, it doesn't.
You know what,
doesn't
you
make any
guys,
sense.
I can't draw this. I'm trying to describe it to you in words, and I will fail miserably if I try to draw it. So I just cheat.
What's up?
I can't cheat
Why can't you cheat?
because I have no yardstick with a hook on the end.
What? How am I a yardstick? Oh, do you need help with being short?
Thanks. I walk away with a complex and a twitch.
I was serious though. Do you need me to pull that down for you, or are you just gonna put it on that?
You know, now that you're saying this, I did forget. Last Friday, I don't think I was insulted once. You guys, I don't want to take a lot of time with this. I don't know how pretty the image will be. Let me give it a shot just for a couple minutes.
It's going to be hideous and beautiful at the same time.
Just look at it as a collection of sine curves that are gradually shifting.
Are you sure that's not going to be e to the x sine y as opposed to?
Yeah.
You need a
Yeah, you
time
need
limit.
parentheses.
Do you think so?
Yeah.
Or parentheses.
Oh, I don't know, let's just grab it.
See what happens.
Well,
Look at this, nothing, just fuck up.
yeah, I would not have thought of that.
God, that did not make it any
Oh, so it's
clearer.
going on forever. Oh my god. Wow.
The page up.
Oh, is it page up? Thank you. Do you guys see how the surface doesn't seem to have any local extrema? Not this is a great image, but you know, it's decent. And see how it's acting sinusoidally towards or along one axis, like the y-axis, but exponentially on the other axis?
Can you put the X, Y?
Yes, I can. View the axes. There they are. Sorry.
That is intense.
It looks like
Yeah,
it's
it's
got
not
some
there.
saddle points though, doesn't it?
Why?
Well, that's fine. The fact that I found no critical points really means there's no local extrema, whether the saddle points or otherwise.
Why is it like two stages almost? Like it has a really thin one going up and then a thick one going down. That makes sense.
Just only because of our perception, we're seeing more of these lines that are connecting the curves. It's nothing more than looking at an angle and seeing a lot of lines simultaneously, or really close to each other.
I mean like that.
You guys, I don't want to take a lot of time with this. I just knew I couldn't draw it, so I'm glad the picture's somewhat decent.
It's a pretty tight picture.
Oh no, you guys! Shoot, my examples are too
Complicated.
No. I hope I have something better. That's not going to work, is it? Oh, I hope I have something. Let me look. Ooh, I do.
Example 6.
Okay, everybody, a whole new question.
Example 6.
Oh, thank you. So list my choice of words clearly. Not the same instructions. I do not want to find local extrema for this function f. I want to find the absolute extrema for f over that closed disk. And to find all absolute extrema over some closed region, xy coordinate plane, I'm going to play this game, which is analogous, to what you guys did back in Math 30. I'm going to look for all critical points on the interior. And then I'm going to optimize in my usual fashion along the boundary curve, which is along the circle. So first things first. On the interior, that really does amount to nothing more than the second derivative test. So on the interior, I will yet again solve a system of equations. Because my first step is to try to find my critical points. And I think this gives me... Anybody? Or... I think I said that poorly. I said or. I should have used a conjunct to connect to the word and. Do you guys think you can just cut to the chase?
0.
Yeah, I think the only critical point is going to be the origin. Am I concluding that too fast?
The exponential function can never be 0. So.
Good, I agree. Like we discussed before. Now that I've got my critical point, I think what I need to do next is, well, find my D function. But my D function's nothing more than this 2 by 2. Which I think it values to the fall. Actually, I shouldn't talk so fast. I have no idea what it values to. So humor me. Is the French technique working?
What's the French technique? Is that really how the French teach?
No, I'm thinking of mine. I'm not talking.
Oh.
I mean, I know in France there's no relationship between the professors and the students. Like, I'd be calling you professor instead of balagai. And I think that's crazy. I can never be like that. Too
How would you
personal.
learn?
What?
How would you learn?
Yeah, they have a different style. Like when I was studying it, isn't it like 11 or 12 classes a day or something like that? It's crazy.
You ever heard of this person?
I haven't ever
How long?
heard that handwriting.
Right after the revolution, he tried to get into the most prestigious university in France, the Polytechnic University in Paris. And he was such a snobbish teenager. He went in there, took the entrance exam, and he looked at the exam, and he thought, this is so ridiculous, it's so easy to get into this institution. And he got so frustrated, he couldn't control himself, and he picked up his eraser, well, the eraser he had for a little chalkboard, and he threw it across the room. Hit the professor at the front, right between the eyes of his proctor of the exam. Put in writing, guaranteed he will not be accepted at that university. So, but he was a great mathematician. So we talked about relationship between professors and students. That came from that.
Just to make it easier, I mean, it's not gonna change anything, you can factor out an e to the x squared minus y squared.
Oh, absolutely. Absolutely. Well, careful. Thank you. If you pull it out, you're going to pull it out of a row in the or column, but you're doing it twice. I agree completely. But I can't assume everybody in this room knows that. Did you know? Were you aware of that with determinants?
You can prove it works just by evaluating the determinant working backwards.
That's true. I see a lot of blank faces. I'm not going to do it. I'll crank this out by hand. I guess that gives me the product of these two beasts. That of 4x squared plus 2 and a 4y squared minus 2 times e to this power.
If there's an easier way, can we know the easier way?
Absolutely. And if you're a Math 33 expert, man, you go through this fast. Is that going to be a minus?
Is that e to the power?
Yeah, e to twice.
Okay.
That difference is a power. I'm sorry, Linda, I'm just trying to beat that clock.
Right.
Is that going to be a minus 16x squared y squared e to the power? And you guys, without cleaning up any further, I've only got one critical point. So without cleaning up, can I just cut to the chase and evaluate my D function at that critical point? I think it's going to give me, I'm not being honest, I have no idea what it gives me. Is that a negative 4? Minus 0, which is just negative 4. But if it's negative, what does that suggest?
Saddle point.
Yeah, they're all saddle points. And so I think here it's going to yield, or this particular function is going to yield no local extrema. Well, that's on the interior. Shoot. I've got some work to do on the perimeter, the border of this particular disk. So on the border, where x squared plus y squared is actually equal to, is 1 or not? So it was a unit disk. If that's the case, then I think this function right here Yes, I wrote it correctly. Simply transforms to a function in one variable, that is to say in x, which by the way, ends up being e to the x squared minus, well check this out. I've got another name for y squared. It's just this. Or shall I say, f of x is equal to e to the 2x squared minus 1. So I think when it comes to the surface, at least on the boundary of this disk, I think that's going to be the equation describing what's going on. That's the function I want to optimize. I want to find absolute extrema for this particular function. Use my Math 30 skills. So using.
I'm sorry, why do we move away from the middle? We were talking about 0, 0, right?
Well, I think when it comes to the closed disk, which by the way is this in the xy coordinate plane, I think when it comes to this closed disk, in other words, everything on the inside and the boundary, I think the surface living up here potentially could have extrema on the interior or on the actual border. Just like back in Math 30 for a function described over a closed interval, as long as you got continuity, you're going to have an absolute max and an absolute min. You call it the extreme value theorem. Still holds here. Over any closed region, the xy coordinate plane, as long as I got continuity for the surface above, I will attain an absolute max and an absolute min over that closed region. I was simply trying to find all critical points and looking at my function value of them on the interior. Shoot, I don't have any. And I want to optimize along the boundary. I mean, when it came to two-space back in Math 30, didn't you guys do this? Maximizing over the closed interval from A to B. Didn't you say the max is going to occur either at the endpoints or at a critical number in between A and B? Well, I did the same thing. I used my second derivative test to find the local max or local min on the interior. Okay, so I'm in higher dimensional space. Now I'm just going to check the endpoints. Oh, but shoot. Unlike Math 30, I guess I've got infinitely many endpoints. So I'm looking at what's going on the boundary of that disk. But now that I rewrote the output of the function as a function in a single variable, this really is a Math 30 game. So use my Math 30 skills to find extrema. For this function that I have listed right above my head, namely e to the 2x squared minus 1, let's play our Math 30 game. I think when it comes to that function's derivative, oh, you guys, it's okay if I walk this fast, isn't it? Isn't that just simply going to be, instead of 4x e to the 2x squared minus 1, and the only critical point I have is that x equals 0. I said critical point, didn't I? I meant critical number. So, help me with this. What do I do next? He said, help me with this. What do we do next?
Two different processes you can take. You can take the second derivative, or you can use number line.
You see, I think when you say it that way, I'm looking for local extrema over this thing. I want absolute extrema, so what do I do? Compare. I evaluate this little function f at the critical number or at the endpoints. I said we're at the endpoints. You know, the ones at the end.
1, 0.
Well, it's just a number.
It's just 0 and 1.
Say it again.
Weren't we evaluating?
Whoa, 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 whoa. You guys, come back over here. What does that graph look like?
There are no endpoints. It's
What does that graph look like? Is he a circle? How big and how small can the x-axis be?
1 or -1.
Thank you. I think I got to evaluate my function at those three critical numbers. And I think I get, actually, I don't know what I get. When I plug 0 for x here, doesn't it give me an output that's, yeah, I agree. When I plug -1 in for x, what does it give me? When I plug -1, I made it backwards, but who cares? When I plug 1 or -1 in for x, I get the same value. Can you guys finish this by putting this in words? What have I just accomplished?
Are those local mins and maxes?
I think there'll be absolute mins and absolute maxes. So I think the absolute maximum z value is going to be nothing more than e. It occurs twice, but it occurs not in the interior, but actually on the boundary. Specifically, when x is equal to -1, but when x is -1, what's y? So I think at -1, 0, or at positive 1, 0, I get the absolute max z value, which in this case ends up being e. But I think at the order pair, 0, 1 or -1, when I solve for y, I get the absolute min z value, which is going to be 1 over e. Do you see it? Yes, Caleb?
I thought absolute had to be one value, or you just have two local maxes.
Ah, but you know what? I do have I only have one absolute maximum z value, it's e. It's just that it occurred twice. It occurred twice over that closed disk. Two different points in that closed disk gave me the corresponding same z value of e, which is the maximum. And I think also I only have one absolute min, but it occurred twice, namely at the point 0, 1 and 0, -1. Are you guys happier, Madeline?
You're saying the critical values, and you're saying it in terms of x.
Yes, I am, because now I'm just traveling along the boundary.
Typically, do we always do that?
Oh, yes. Matter of fact, from here on out, if I ask you guys to find the absolute extrema over some closed region in the xy coordinate plane, you're going to do this. You're going to find all critical points on the interior and see what the corresponding y value is. Sorry, I misspoke. See what the corresponding z value is. Drop it like a rock. Now force yourself to be on the boundary of that region in 2 space. That means just the edge. Use that to convert this function in 2 variables into a function in 1 variable, and I'm going to stop talking. Use your Math 30 skills to find absolute extrema on the boundary, but compare those values to what you found in terms of critical points on the interior as well.
I don't get how we know something important is not happening when y is 1 or -1. Or like we're just looking at
I see your
the
point.
expression.
You know, Caleb, I should have said that. I think if instead of rewriting this output as a function in just x, but a function just in y, I know I would get something slightly different here, but in the end, that would generate the same darn 4 points. It really would generate the same points. It would just been in terms of y. I'd have to find the corresponding x values, but you find the x values are going to be 0, 1, and -1.
So it's really 4 points where there's an absolute.
Yeah, do you see why it's 4? Here's 1. Here's a second. You see those 2 of them. Because if x is equal to 0, when you solve for y, don't you get plus or minus 1? So relative to the boundary curve, I think when I found the critical number being 0 for x, it really gave me 2 corresponding y values, 1 and -1. That's why when I glance and list these 3 equations, I see 4 points. 0, 1, 0, -1, 1, 0, and -1, 0. I was just trying to take liberties and beat that clock and not writing it down.
Is that because it's symmetrical or always?
Well, I suppose you're right, it is symmetric in this example. It's just that I was really looking at the constraint equation when I determined that I'm going to get 4 points for which I want to evaluate the output of my function. You know, I could have done something different. I could have said this.
Isn't one of those points at the center?
Oh, I'm sorry.
Aren't one of those points at the center?
No, as a matter of fact, at the center, when it came to that critical point in 2 space, it gave me a d value that was negative. So it gave me a saddle point. And so I don't think that point 0, 0 in the center of the circle yielded any active extreme in this particular case.
So if you had yielded something, we would look at that point in addition to the ones that we found in the, and then.
Oh yeah, if I had found a critical point at 0, 0 and b was positive, I would have just stopped and evaluate my function there and compare that to the outputs I got here, here, and here. And see which one's the largest, just like you did back in Math 30.
So, but on that first part,
Yes.
that was for the whole function, basically, wasn't it?
True, but when I played this game, I was applying a second Derivative test. I was only looking for local extrema on the interior. And so when I say on the interior, I mean.
But we haven't, at that first part, we haven't even considered our little circle yet.
Good point. Yeah, if I yielded a critical point that actually was not on the interior, I would have just said, don't worry about it. Who cares if it gives a max or min? I'm only caring about what's going
So
on
we-
on the closed disk.
We're just seeing if this critical point we got was on the interior of that function.
Yes.
Okay.
And you know what? Now you mention that, I might have just wasted your time, you guys. Technically speaking, I don't have to go through all this garbage. You could just bag everything and say, well, evaluate the function at those endpoints in terms of x done. I could also evaluate the original function when x and y is equal to 0, and I think I simply get, in this case, a 1. And be done with it. And realize one's not the biggest or smallest. I could have avoided all the work on the interior. It's just
Yeah,
my first
but on this-
discussion.
Yeah, but this particular function, it was that easy, but not always.
True,
So,
I agree.
In the first part, we dismissed it because it was a saddle point, but couldn't a saddle point be an absolute maximum and minimum?
It was small.
You know, you've got a good point, but if it ended up being an absolute max or absolute min, I would have been able to find it on the boundary curve. It would have been on the boundary curve.
Wait, why? What's that?
Because if it weren't on the boundary curve but on the interior, then necessarily that point yields neither local max nor local min. And therefore, it couldn't have given me the absolute extreme one. Because if I had a saddle point on the interior, then since that saddle point for free is neither a local max nor a local min on the interior, then it certainly can't give me an absolute max or an absolute min over the corresponding closed region. That means including the boundary.
Okay, yeah, I see.
So the only time that your saddle point is going to actually give you an absolute max or absolute min is if it were occurring actually on the boundary curve, and you would have found it eventually.
Or everything's like flat.
No, it doesn't have to be, but I see your point.
Sorry, it only ever goes down and otherwise it's flat.
Good. Madeline?
So if you had found a critical point on the inside,
Yes.
you would have to then evaluate it and then compare it to boundaries, like not a normal, like you.
Yeah, you could have done this in example, watch. I really did find a critical point. And if I didn't go through all this work, I could have just said, well, plug 0 in for x and 0 for y in the original function, see what we get. Oh, it's 1. It's just that one's neither bigger nor smaller than those numbers over there. So it necessarily did not yield an absolute extreme because
What's saddle mean?
a saddle point is simply a point for which it's neither a local max nor a local min.
Yeah, okay.
Is it kind of like an inflection point in a 2D?
It doesn't have to be, because look at a paraboloid. Any point except for the vertex is going to yield neither a local max nor a local min. So I think when the d function ends up being negative, that's what's going to happen at those other points. And certainly I couldn't discuss some kind of change in cavity at that point that's on the surface of the paraboloid.
And you said it's positive,
If what's positive?
the determinant.
Well, I think if your d function is strictly positive, then you got a local max or local min. You have determined which by looking at the second partial for the original function f. Better? Caleb?
Is x squared plus y squared less than 1 or equals 1 just something you gave us, or was it significant, like something we came up with?
No. It's something I made up out of thin air. I said, let's find, I didn't write it down, Caleb. I said, let's find all the absolute extreme for f over this closed region.
Gotcha.
Now, I could have described it this way, over a triangle, determined by, say, 3 points. I'm making these up out of thin air. But in that case, life's a little easier because I think the boundary's linear. It's a little more difficult in the sense that you have to come up with equations of those lines, or the line segments, and play the same game I did.
So one more question. On that first part, then, it's possible to find a critical point that's not in our restricted area.
Yes, absolutely.
And so then we would reject
No
that.
pun intended, sorry.
Yeah.
Yeah, if you found a critical number that's not on the interior, just go and throw it away. It's not important to you because you're trying to
Because
optimize.
we have limited our domain or whatever.
You've limited your domain
Right.
to that closed interval or closed, not interval, closed set in the XY
Right,
plane.
okay. So we're just doing, in general, for the function for the first part. Now, because we've given a closed area, then we have to play the other game.
I agree,
All right,
on the boundary. Caleb?
yeah.
Yeah, these were all
I see
solved.
Caleb sign.
These are all solved for z basically, right? So if it wasn't solved, so if we were given an equation that wasn't solved for z, we'd have to solve it, right? And then, or am I
Oh.
completely off the mark here?
You know what I would do? I completely give up. And I simply relabel whatever variables isolated as z.
Okay.
And go for there, because I need a function. Z's got to represent a function. And so, and I can play the game I'm suggesting by just simply rotating the three-dimensional coordinate axis system, by replacing maybe the variable x with z. It just gives rotation, and I can play the same number.
Right, but then you get an absolute max or min in a different direction, right?
That's true, you're right.
So you'd have to account for that somehow.
Absolutely, I agree. So everybody, homework. Sorry, I need to organize before I lose it. Oh, shoot, I can't. Brad, may I?
There you go.
Thank you
Just
very
don't
much.
break it.
Wait,
It's almost dead.
like I said, good fire starter. Section 12.7. I like the odds through 39.
Wait, what?
The odds
I like
through
the odds
39?
39.
Okay.
Odds through 39?
Yes.
What section?
It's 12.7. I like 43 through 47 odd. And I apologize for this only because I've come across so many students who've never heard this. Can you look at number 50?
What's 50?
One of your favorite formulas in geometry, Heron's formula.
What is it
Yes, yes,
Aaron?
exactly. I remember
Never heard
that
of it. What
perfectly.
is it?
Oh, dude, you're killing me. This is a way to compute the area of a triangle just by the sides. Heron's formula says the area of a triangle could be inserted as a square root of s times s minus a times s minus b times s minus c. Where a, b, and c are the lengths of three sides of any triangle. S is a semi-perimeter.
Why are you integrating something in?
No, I'm not.
Oh, okay. Okay.
Let's see.
All right.
No, I wasn't going that far. How about 55? Oh, I like 58. Oh, you guys, don't get mad at me, but I'm not finished. In section 12.8,
Wait, 12.8 as well?
oh yeah, 15 through 47 odd. Guys, I want to give more. I just have to give you an example of an application, so can I just hold off till tomorrow for that? Tomorrow being Friday. Can I bag the quiz since I wasn't here Monday? Can I just instead give a take-home quiz?
Sure.
I don't have anything really interesting, but I can play some really good games with you.
Okay,